Hello and welcome to CS260. In this class we will be focusing on getting some understanding of how functional programming works using the language Haskell to better round out your knowledge of programming in general. Now you might not go on to work in functional programming as a field, however the tools and the techniques that you learn in functional programming will inform your abilities as a general purpose programmer. So let's get started. What I have here is I've got a little bit of imperative code that we're going to translate into Haskell to see what the differences are. Now, I've got a little bit up at the top saying imperative versus declarative. Now, Haskell is a declarative language. The difference between imperative languages such as Python, you could say Java as well, C, and the difference between imperative languages and declarative languages like Haskell are that declarative languages focus on telling the computer what to do, not necessarily how we will do it. We don't have to worry so much about updating variables, storing values, putting them in the right place, calling the values back. We really just worry about telling the computer what it should do and let it handle all the hard stuff for us, which is a nice way to work. You'll also have heard that Haskell is a functional language, and that's true. Functional programming is a type of declarative programming. So functional programming focuses on function composition as a means to simulate computation or to create computation. So we worry about chaining functions together. This allows us to build a tremendous amount of complexity very quickly because we can build small testable areas of code, and then we can chain them together to get an extensive or incredibly complex thing out in the end. That's why Haskell is very good for rapid prototyping. Anyway, so you'll see here, I've got a little function written in an imperative style. You could say, if you could think of this as Java or C or something like that. And all it's doing is it's taking a number n and it's summing all of the numbers up to n. And you can see for this example, I've got quite a few variables. I've got a couple that are just storing the results, a couple that are counting for me, and I've got a little while loop. And then once I've done all that, I return the value of k. So how do we do this in Haskell? Well, let's see. The first thing that we need to be aware of in Haskell is Haskell has something called a type signature. Now, for most of you, I think most of this class will have done CS106 with Connor. You did that with Marks. If you haven't seen that, don't worry, we'll see plenty of examples as we go through this class. But you do implicitly have one of these when you're writing Java code. I mean, we have a return type here. This is the int here. And then we have the type of the parameter that's being passed in here. So you do have to do this in Java. It's just it might be more hidden than it otherwise would be in Haskell. So what does it look like in Haskell? Well, we declare the name, so we call it sum. A couple of colons tell us this is a type line. And we say this takes an int, that'll be our integer n that we're taking, and it returns an int. So that's it. This is a simple function. It takes one thing, returns another. So another thing that's interesting about Haskell and declarative and functional languages in general is that as a rule of thumb, we don't have explicit loops. So we don't have the ability to just say while do this. We have to use other means. And that main mean is going to be recursion for a lot of you. We'll see other things like traversables later on, foldables, things like that allow you to do this in different ways. But at the moment we're just going to be focusing on simple recursion. Now, I would try not to worry about recursion too much. We'll be getting plenty of experience with it in this class, and we're really just going to use it to abstract away doing more work than we have to. That's all we're doing with it. Okay, so if I'm going to do this recursively, one thing I'll need to think about is a base case. When we're doing recursion, we generally need a base case. So if I start by working my way back from n, so I do n plus n minus 1 plus n minus 2 plus n minus 3, eventually I'm going to get to 0. And so I need to specify what's going to happen when I get to 0. So let's do sum of 0 equals 0. Easy peasy. Now this is a very basic example of something we call pattern matching, which is when we just match based on the input we're given and tell it what the output should be. This is a very, very powerful tool in functional programming, but we'll see more of that as we go. So we have the first case. The next case should be when I have just a generic integer n. In which case, what I'm going to say we should do is n plus sum n minus 1. And there we go, it's filled out the brackets for me, isn't that lovely? And so that will just recurse through until I get to 0, adding all the numbers up, and that's my function done. So you see that this is very, very concise code in comparison. I'm sure you could make the previous example much more concise, but you can see that the simple Haskell version is very easy to interpret and very straightforward. Now, remember, if you're specifying this type here, you always have to return an integer. So this is what this base case is doing for us. And this is why this case, it's alright to add this thing to this number in here, because they both resolve to integer types. You see this quite a lot. Well, I've been telling you quite a lot of this in the SAS 207, but making sure you understand what your types resolve to. Okay, so we have our code, which is great. Let's see how we run it. So there's a couple of ways. You can either do stack GHCI. I'll do it the long way around. And Bob Ackey's video, he just loads the file in straight away, so you've seen that version. So you can do it that way, or you can just set up stack GHCI and then :L. If you hit tab when you're loading something in, it will try and figure out what the rest of the file name is, which can save you some typing, which is nice. And there we go, we've loaded it in. So let's do the sum of all the numbers up to, let's say, 10. And there we go, that's how we run our code in Haskell. So it's fairly straightforward. While we're in terminal, I'm going to show you another couple of tricks which might be useful for you. There is a few commands which can make your life a bit easier. One of them is :T. This is something that you can apply to a function to get its type back. So if I type :T into the terminal and I do sum, then I get the type that I specified. One thing I can do, because Haskell has type inference, is if I comment this out, I come back in here and I reload using :R, that's the reload command, and then I try the same thing again. Haskell will try and infer the type for me, and you can see what I've got there is a lot more complicated than what I specified. So you can let Haskell infer the type. In this class, I'm going to insist that you have that you write the types yourself, mainly to enforce your own understanding, but also you can get something more generic than you want, which can result in behavior you don't want if you don't specify the types yourself. But you can also use this in library commands that you haven't seen yet, but like if we use $R, you can see that's got a really complicated data type there. We'll be getting onto stuff like that later on. There is also the :I command. This is something that I'm just going to show you for the sake of completeness. This will tell you a bit more. So we try this in $R. You get a little bit more information. However, I would say that it's best to stick with :T. It will just return the type, and by and large, that's all you will need. You won't really need :I. One thing that we should also do while we're here is Haskell evaluates cases in a case-by-case manner. So it starts with the first case, checks the input to see if it matches. That's the pattern matching I was talking about earlier. And if it doesn't match, it then goes on to the next one. Or if it does match, it just does that one. So if I copy this or cut this out here, and then I paste it in here, you can see I have a warning already. That's because Visual Studio has some very handy plugins. And it says overlapping patterns warning. Now that might be confusing to you, but let's see what this means when I try and run this. So I get another warning saying overlapping patterns, pattern matching is redundant, an equation for some n. So it's saying that the 0 case is now redundant, which it wasn't beforehand. So what's going on? Let's see if we try and do sum 10 again. Now we enter an infinite loop. This is because the pattern is already matched by the first case. So 0 is just an integer, and in the case above it, with n, this is just an integer. So it's saying, okay, well, every time I have an integer, I can match that to n. So why are you giving me this second case? Because I will never reach this, because it's a subcase of the first one. So in Haskell, you will want to be wary of how you order your cases. They can cause unexpected behavior like that, or they can just lead to logical errors because the patterns are matching in different ways. So it's very important that you're aware of how your patterns are being matched as you go through. So that's everything for today's video. I hope you found this useful. This is a very basic function. I just want to show you a rough idea of how we get started in Haskell. We'll be doing more complex stuff as the week goes along, but this is just to give you a rough idea of how we'll work in Haskell. That's it for today. If you have any questions, please do feel free to get in touch. Thanks.